Hi everyone, I'm Frank Lubiga. I'm a participant of the recent Kaggle 5-day AI course with Google. I'll be demonstrating my project, my Capstone project, where I built a stock analysis chatbot to provide concise and relevant financial insights and information to users. And I'll be walking you guys through the codes and explaining the technical aspects of the project. I hope you guys really enjoy the process till the end. All right, guys. So this is a notebook. This notebook has been made available on Kaggle. I've shared the link below. You can click the link in the description below and you be able to get access to it. And you can run the codes one after the other. I'm going to be explaining the codes here as I want them. And I've also shared a link below with the link to the article I've written on LinkedIn. The article explains more about the process that was carried out here. All right. So is the notebook. And like I said before, this I built a stock analysis chatbot which helps users with concise financial data and insights regarding a particular stock or a set of stocks, all right? And the process involved getting data, real-time data from Alpha Vantage API and analyzing this data to calculate technical indicators like the simple moving average, which helps determine a bearish or bullish signal, and also the relative strength index, which helps to determine if a stock has been overbought or oversold. And I also made use of Retrieval-Augmented Generation, RAG, to enhance the model's ability to provide responses that are relevant. All right. And also, I was able to fine tune a Gemini model. And I'm going to demonstrate how the fine tuned model demonstrated more capacity in providing financial analysis than the primary model that's not been fine tuned. So when you get access to the notebook, we want this cell, you can press Shift and Enter on your keyboard to run the cell. Then you want this one to install the Google package that has the models and also install the vector database. In this case, we're using ChromaDB as our vector database to store the vector embeddings that we're going to generate in this project. And this code is we're going to import the necessary libraries, which we're going to use. And this way you set up your API. So you need to go here. Hope you can see the screen. Go to add-ons here. Let me All right. So you go to add-ons here, click on add-ons, click on secrets. Okay. Then you come here, add secrets. You enter a label. So you enter Google API key, this, see this, you copy it, and you enter it as a label here. Then you enter your Google API key. To get your Google API key, click here, AI Studio, and it will direct you to where you are going to get access to your Google API key to make use of the Gemini models. Then you also create another secret here, whereby your Alpha Vantage, whereby you're going to store your Alpha Vantage API key. So you create another secret, just come here, click add secret, and you use Alpha Vantage API key as a label. And to get your key, click here, Alpha Vantage is going to direct you where you're going to get your API key. All right. So we want this code to set up our API keys. It's loading. All right. Then this code is look at a list of models that are available and also the list of embedding models that are available. So what are embedding models? The embedding models are used to generate embeddings for our data. And embeddings are useful because they enable augmented retrieval of information, whereby information is not retrieved based on keyword similarity, but based on semantic similarity. All right, so the model does not, which, for example, let's say you give a query to the model and you tell the model to get to produce a picture of a cat, or I produce a picture of a cat, and the model notices that your query matches what is in the database word for word. The model is going to generate that image, all right? But the if your query doesn't match what's in the database word for word, the model won't be able to generate. So that's why embeddings are used. Instead of models to generate based on keyword similarity, it does that based on semantic similarity, right? So it understands the underlying meaning of the query before it retrieves information. So here's a list of available Gemini models. In this project, we made use of Gemini 2.0 Flash, made use of this one. And these are the list of the embedding models. These are the list of the embedding models. So let's try to query our Gemini model and see. This model has not yet been fine-tuned. It has not yet been fine-tuned. So I'm going to query it and we're going to see the kind of response it produces. So the query here will be compare the trends for Google and MSFT. All right, so we're telling it, here's a query. We're telling it to compare the trends for Google and MSFT. And when you run this, you just wait for a while for it to generate its response. Now look at it carefully. You notice that in this response, there's no technical analysis. You don't see any technical indicators and the response. The model is hallucinating. It's just generating tokens without tokens are not relevant. And the response is not concise, the response is not helpful, right? So if you go through it carefully, you notice that this response is not helpful at all to the user's query. Now let's give it another query. Let's ask the model to tell us the relative strength index of Google and Microsoft stocks, all right? So this other query here, I've given the model. So let's run this. So let's look at what it says. It says it can give you the exact real-time RSI values for Google MST right now, right? The reason why it can't do that is because this model, without being fine-tuned, does not have access to real-time data, real-time stock data. It doesn't have access at all. So that is why we're going to fine-tune our model to have access to real-time data. And we're going to store this data in a vector database, which is ChromaDB in this case. All right. So this is the code for us to set up our vector database. You can see the output here. It says, here's the output. It says ChromaDB collection stock analysis query. So we have, yes, what that means we have not yet stored any documents yet in the ChromaDB database. All right. So next we move to storm data fetching. I built a fetch stock data function. It fetches data from the Alpha Vantage API, and it formats the data, all right? So let's run this, all right? So we've given it a symbol. So it takes a symbol and then generates the data for that particular symbol, all right? So let's fetch the stock data from Google symbol, right? From Google stock data. So we can look at the open. Here's the most recent data down here. So on the 16th, which was yesterday, the market opened at $153.1 and it closed at $153.33. And the highest value yesterday was 155 and the lowest value was 151, indicating moderate volatility in the stock. And we can see this is the amount of shares that were being bought or sold, that were being traded in the stock market yesterday. Let's look at Microsoft. Let's fetch the stock data from the Microsoft symbol. So as of yesterday, Microsoft opened at $380.67, closed at $371.61. The highest price there was 381.6 and the lowest price there was 368, indicating moderate volatility as well. And this shows the amount of shares that were traded yesterday. This code just shows the most recent data. Next, we're going to analyze these stock trends and calculate the technical indicators, which are the simple moving averages and the relative strength index, right? Relative strength indices. So these are the functions that I created to so we want this function And you want this. Let's get the analysis from Google Stock data. Google Stock data. So this, as of yesterday, this is the current. This is the closing price as of yesterday, and this is the rolling volatility. 30 days rolling volatility. 30 days high, 30 days low, 30 days average price, which is the simple moving average, and the last volume as of yesterday, 30 days average volume, and the trend, which shows that it is down currently. So after analyzing the Google stock, we will compute the latest trend index and also compute the simple moving average of that Google stock over a specific time period. So in this case, we're calculating the RSI within a window of 14 days, or calculating the SMA within a window of 30 days. All right. So let's run this and let's look at this. So he has calculated the RSI for the Google stock. As you can see, here it is the output. And let's get the SMA on this. All right, so what does RSI tell us, right? So RSI ranges between 0 and 100, right? It means relative strength index ranges between 0 and 100, and it helps determine if a stock has been overbought or oversold, right? And when the RSI is around 50, it shows that it's a neutral, the stock is in a neutral condition. That is, it's neither potentially overbought or potentially oversold. But when the RSI is above 70, shows that the stock is potentially overbought, and if it's below 30, shows that the stock is potentially oversold. So in this case, for the Google stock, we consider RSI as 43, which shows that it is neutral because it's around 50. And when we look at the simple moving average, the moving average, we'll look at it. All right, so when we look at the simple moving average here, over 20 days, it's 157, but over 50 days, it's 168. All right, so when since the simple moving average over 20 days is less than or is below the simple moving average over 50 days, it shows a bearish signal. It shows a bearish signal, as explained here. So when the shorter term is above, it shows a bullish signal. When a shorter term is below, it shows a bearish signal, suggesting that there is a potential downward movement in the stock, and it is prudent for you to sell the stock. Since there is a potential downward movement, it's prudent to sell the stock or you avoid buying the stock, right? So in this case, when we look at this, the SMA 20 is below the SMA 50, showing a bearish signal. But I want you guys to take note that this analysis was made using a non-adjusted time series data. All right, so the analysis will not be too accurate. All right, so I use a free Alpha Vantage API, and that is why I couldn't really get access to the adjusted time series data. So we have built the functions to calculate the technical indicators, which are the RSI and the SME. Next thing, we're going to build a function that will help us to store this analysis in our vector database. So run this. Run this. Now you can see that we have one document in our collection right now. Well, it means it has been stored. And when you look at it, this is what has been stored in the collection. So this function here will help us to retrieve data from that database, which is the ChromaDB, helps us to retrieve data for a given query. All right. All right, so here's how it works. It retrieves this particular data for Google. Okay. Then this function helps us to extract the symbols from the query. So this function extracts multiple symbols, extracts symbols from the query, then due to the number of extracted symbols, it's able to determine if the user is seeking for a single stock analysis or a multiple stock analysis. All right. So I gave it this query. You can see it here. I asked it, what is the trend for Google MSFT? And these were the symbols that were retrieved from the query. It retrieved Google and it retrieved MSFT, which is Microsoft. Then we're going to build functions that will help to orchestrate both the single and the multiple stock analysis. All right. And we want this string, this one. So this build comprising context string, it just helps us to get the context that we're going to use, that we're going to include in our prompt, right? And this prompt is what we guide the primary model to generate responses, all right? And so this is a context string which has been built. Then here is a comparison prompt, right? Let's see, it says here that you are a stock market analyst assistant. So I've given it a role, right? I've given it a role, and the user wants you to compare multiple stocks, right? So this is a comparison prompt. Whenever the user is seeking for comparison, right? This is a prompt that will be generated. So I gave the model specific instructions within the prompt so that the model will be able to generate relevant information in regards to the user's query. Okay, so let's run this. Then this is the evaluation prompt. So I build another model, which is the same Gemini 2.0 Flash model, but it's separate from the primary model. And this other model would act as a judge. So once the primary model generates a response, the evaluator model will evaluate that response based on a particular criteria which I have given it. All right. So it evaluates based on, is this response helpful? Is this response concise? Is this response justifiable? Is this response grounded? All right. So that is what it does. So I want this function. So this is the evaluation criteria. relevance, is accurate, clarity, is a response easy to understand, helpfulness, does a response provide useful insights, and so on. Then we gave it a query, and asked the model to compare the trends for Google and Microsoft. All right, so this is a comparison query. Okay. Then once we give it this query, it builds a comparison prompt. All right, then it puts in that comparison prompt as well as a query into the, then it gives the comparison prompt as well as a query to the primary model to generate the response. And then the judge model will evaluate the response from the primary model. Let's be waiting. Yes. All right. So this is the response. So here's a comparison of trends for Google and MSFT based on the provided data. You can see, do you see how different this fine-tuned model is from the non-fine-tuned model? It provides real-time analysis. It has access to real-time stock data, and the information, its response is concise, and it has a lot of clarity within it. So it's very, very different from what we had before. Look at what we had before. So I gave you this query here, said compare the trends for Google and safety. So look at what it does. It starts hallucinating, it starts going off, off the query, going beyond what the user asked for. Start generating a lot of information that are not relevant. All right. But after fine-tuning this model using Retrieval-Augmented Generation, we were able to get a much more concise response, much more relevant response, and much more helpful response. All right, so this is where we stopped. So you can see it says a simple moving average is a technical indicator of business average price. So it explains what these indicators are. It gives the user a comprehensive overview of its response. Okay, so the user will not be lost. So whether you're an expert or you are just a beginner, it helps you. It helps you to understand the trends about a particular stock. Very important. And these are the evaluation results. These are the evaluation results. He gave it a score of 5 on 5 when it comes to relevance, 5 on 5 when it comes to accuracy, 4 on 5 when it comes to clarity, 4 on 5 when it comes to conciseness, and 4 on 5 when it comes to justification, 5 on 5 when it comes to helpfulness. Right, when you have time, carefully go through this, you're going to see how well this model performed. And we move from multiple stock analysis to single stock analysis. And we're going to run this build a single stock prompt. So whenever the user's query involves a single stock, this function builds a single stock prompt, a prompt for single stock analysis, right? So it's different from the comparison stock prompt. Take note. All right, it's running. All right, done. So we want this to generate the response. All right, so this is a query. What is the current trend for Google? This is a query we're giving it. Let's run this. All right, very concise, straight to the point, involves static analysis helpful. So based on the provided data from the response, it says, based on the provided data, Google's 30-day trend is down with the current price at this, right? So you can see how different it is um, from the non-fine-tuned model, which doesn't have access to real-time financial data and stock data. I think the Gemini model does not be fine-tuned, has data as of 2023. And I think beyond 2023, it doesn't have any data that it can work with. And these are the evaluation results. It had a very good score when it comes to relevance, accuracy, clarity, conciseness, justification, and conciseness. All right. So I've come to the end of this. And here we're going to, this function is the main function of it all. So it combines all the other functions that we have built in this project. It combines everything together, right, to generate and evaluate the, to generate a response based on the user's query and then evaluate the response. So it combines all the other functions. It is the central piece of the project, all right? So on this, all right, so I've given it two queries here. We're giving it two queries and it's going to generate a response based on each of these queries. So the first query is, what is the current price of gold? I want to check if it's going to give a concise response, right? I want to check if it's not going to hallucinate. And the second query is, what is the RSI of APL and TSLA of Apple and Tesla? So we're going to, once it's code, I'm going to see how the model will respond and we're going to see its evaluation results. So that's what it is. So press shift and enter at the same time. So as you can see, it's running. It is running. And let's see. So it generated a response. And the response was the current price of gold is $153.33, which is very concise and straight to the point. All right. There's no need for further explanation when it comes to this query. There's no need. And you look at the score, he has a score 5 on 5 on everything. Everything. And the next query, what's the RSI for APL for Apple and for Tesla? So it gives the RSI, then it explains to the user what RSI means, okay? And then it also explains the technical, it also interprets what the RSI means. So it tells the user what RSI means, it defines RSI to the user, and then it interprets what the RSI signifies. So so the model said the RSI for AIPL is 41.55 and for Tesla is 43.6. And at the end it says both AIPL And Tesla have RSI values in the neutral range. So it gives, it interprets the output, it interprets to the user what these values actually signify, which is very, very good, very good. And this evaluation result, which shows remarkable results indeed. So we've come to the end of this project. So we have seen how I've been able to walk you through um, the steps I took to build this chatbot, how this chatbot surpasses the Gemini model that's not been fine-tuned, how this chatbot provides responses that are up to date, that are grounded in up-to-date real-time stock data, and how this model does not hallucinate, right? So it gives the user what the user wants. Very important. And this project will be very relevant for those who want to understand trends about a particular stock, right? And those who are beginners. So it helps them to get insights on stock analysis. So what is the future work here? Future work here will involve me getting access to a premium Alpha Vantage API so that I can make use of the adjusted time series data in order to improve the accuracy in the model's analysis, right? So consider multi-turn conversations and maintaining user context, right? So make it a chat, make it a conversational, make it more conversational. Yeah. So the next thing is incorporate use sentiment analysis from financial news outlets, implement predictive analytics and forecasting models in order to forecast into the future, offer more advanced technical indicators to provide more relevant analysis, develop more sophisticated natural language understanding for complex or ambiguous queries or important, develop more granular and objective evaluation criteria. That one is also important as well. Incorporate user feedback mechanisms for continuous improvement. Very relevant, very relevant. And finally, to develop a mobile application for wider accessibility. So I can build a web app to demonstrate this chatbot, and I can also publish this web app and deploy it on a cloud platform with time. Thank you very much. Thank you. So I hope you really enjoyed. So I've shared a link to the notebook on the description below. You can get access to the link, you can get access to the notebook, you can carefully go through the codes, all right? You can make your own changes, all right? And if you have any problem, you can just feel free to comment, and I will try my best to be swift when it comes to replying your message. And also you can get access to the LinkedIn article. The link is below. All right, the link is below. Get access to the LinkedIn article, read it, and try to understand how I was able to carry out this project step by step. All right, thank you very much for staying to the end. I hope you really enjoyed it. God bless you.